So our first speaker for the next session is Oliver Tian. Oliver Tian comes with an enormous amount of experience in industrial AI, robotics. He's been around here for over 35 years in the industry. He knows robotics inside out, and he's also the member of a lot of associations that include, he's the vice chairman of the International Alliance of Robotics Association, amongst others. And therefore, we thought he's kind of the right person to get us started on the next sessions regarding artificial intelligence for industry. So without taking more of your time, I know we're running a few minutes late. I will call Oliver over. Oliver, over to you. Thank you very much.
Thank you, Vikram. I hope we have a good meal and have enjoyed yourself. Robotics and AI is actually one of very interesting space that I play with. For those of you who are in AI, you remember those days where we were working on Mycin, fuzzy logic, expert systems, Lisp programming, Prolog. Yeah? For those of us who've been in the AI space, that's where I was born. Right? And over the years, I guess I went through one terrible winter where things just go slow. Of course, nowadays, things get so exciting again with Gen AI, embodied AI, AI agents, and you name it, right? It's quite exciting. The question really is going to be, what really is AI? And many people throw in the term AI, Gen AI, without really fully understanding what that technology will do for you. I'm going to try to address some of those issues, right? But because of the 20-minute time limit, I will be very focused around application of AI in the industrial space, right? So as Vikram explained, I do carry a couple of responsibilities. I used to do my AO myself. I ran the Singapore Industrial Automation Association in Singapore for 6 years. Nowadays, I do a lot of work with startups to look at their technology, cross-border evaluation of technology, helping them with pilots. I belong to two international organizations that's listed there. The Global Robot Cluster, which is based out of Daegu in Korea. That's a network of 30 countries around the world. And then International Alliance of Robotics Association, which is based out of Hangzhou in China. So in that sense, we actually have a good mix of East and West, and we work very closely together in many ways. Let me start off with this slide. I think skills is something that's evolved over the years. This morning we talked about the Industrial Revolution 1 to 4, and 5 is like at the doorway, right? The issue is as we start to look at technology and how technology is helping us, clearly our skills expectation has also evolved. Now that's just three evolutionary line, but it clearly is moved to the space whereby we are demanding that there's a higher need of skills in intelligence. Now, in fact, I was just talking to some friends over the weekend, and they say, hey, maybe it should be an intelligent revolution 5.0 instead. Well, maybe so. The big question is, if I use the latest term, AI agent, what do you expect the AI agent to do for you? If I look at generally the AI technology, what do you expect AI to do for you in the industrial space? And that's kind of a big question. Many people just throw in the word AI, machine learning, deep learning, agentic AI, generative AI. The question is, when I peel the onion further and I ask, what do you want to do with AI? This pause, right? The question is really, why do you need AI? One wonders why. So let's talk about what is AI. So many business leaders think of AI as this. I throw in the data, it goes through this black box, and out comes the value, the outcome that you want to achieve. For those of us who understand AI, it's not as simple as that, right? It is a whole mix of different components required to perform the task. In fact, I was just reading an article recently that basically says that today, when a human performs a task, we evaluate, we determine if there's any additional issues, we try to train the next generation, we document the way we solve the problem. But with AI, it jumps across orders and gives you an outcome immediately. When we use AI to do a program code, how do you debug it? The documentation may not be as effective as what a human would do. So there's a lot more we need to think about when we start to adopt AI. And in particular, in the industrial AI space, the question is Gen AI the answer for you? Let's pause for a while. Is Gen AI the answer for you? What do you want AI to do? And my proposition to you is Gen AI is good for generating content. It helps you with a lot of summary, right? It paraphrases things for you, but it doesn't solve your problem. In industrial AI, you need AI to help you solve problems. Problem solving is one of the key aspects why you want to use AI. And that's a big question, right? In the shop floor, in the assembly line, when something goes wrong, you want to fix the problem. What do? Can AI help you with that exercise? I used to play chess when I was in school. I love Gary, except that he lost to the machine many years ago. Yeah. Today, he's started to look into AI, and he made this comment recently. We do not need less technology. Technology will continue to evolve and get better and better and better. In fact, what's more important is we need better humans. We need to upskill ourselves. We need to get to know and understand what technology can do for you. And more importantly, how do we leverage this technology to augment our capability and extend our potential? Another quote, Albert Einstein, he said this: insanity is doing the same thing over and over and over again, expecting different results. It is probably timely that we start to think, with AI technology, what can we do different? How can we work on things differently so that we can get better results, better performance? And in this morning's discussion, there are several examples. I like what we're talking about this morning because it points to the fact that we should consider using AI in a very different way. In the presentation just before lunch, right, Roy mentioned a very powerful use of 5G. Before, we could never have got remote consultation effectively. But with 5G, we achieved that. And that's what I mean. How do we understand technology in order to leverage it to augment our capability? Well, we say, hey, we have machine learning or deep learning. We've got large language models. Let's try this simple test. Right, in my data set up there, 1999. Well, 1888, 1888, 1777, 1777. So if now I throw a question to the computer, to AI, and says, what is 1111? What do you think happened? Based on that data set, you may get 1919. Right? It follows the pattern. Yeah? And that is the big challenge, right? Depending on the data set that you have, your AI is going to depend on that and build the next level of intelligence. And that's why it's so important we have got good data. We talked about that this morning. Good data, useful data that can help you establish the right intelligence you want to use. Which brings me to the next point. Artificial intelligence is not good enough by itself. It has to combine with human intelligence to make it what I call authentic intelligence. Intelligence that's really good, that's a combination of what us as a human can do, and what machine can supplement, can augment to you so that you can perform very powerful performance or give very powerful performance. So this discussion of intelligent robots, which is one of my favorite topics, how true is this? Right? We ask ourselves, right? Can a robot really be so intelligent? Can the humanoids be so good that it replace the human in performing the job? So let's explore that topic, right? And let's see what it means. And to do that, let me try to explain a bit about reasoning. What the machine can do very well is what I call deductive reasoning. Based on certain data, based on certain information, it deduces what's next. It's got a power to search, to go through a huge volume of data, and it deduces what's next. And it does it very fast. right? For us, we take time to search the libraries, the internet resources to do it. So when we try to compete with AI on deductive reasoning, no game, right? The next level is what I call inductive reasoning. In other words, now we try to take it further to develop a model, to use the model for us to do better with our decision making, to do better in our performance. Now, in that space, AI is getting better and better. Large language models, small language models, embodied AI, you name it, right? We are getting better and better. AI is getting better and better, right? But we still have the advantage. Humans still have the advantage on that. In the last category, what I call adaptive reasoning. Now, this is different. Many of us are business leaders, and you have a council, a board, you run into trouble, and you look at all the data in front of you, all the reports in front of you, and say, what do we do next? What is our best guess? Sometimes our best guess is probably the best decision for the business to solve the problem. And AI cannot give you that best guess. This part of adaptive reasoning is a very powerful reasoning skill that stays within a human being. And if we can combine all these three together, use the power of speed, volume, scale to do deductive reasoning, let human play the role of adaptation. I'll give you an example. Most of us watch Iron Man. Iron Man has got this invisible partner called Jarvis. Just another very intelligent system. Well, nice name, right? But what does Jarvis do? Jarvis does all the data collection, searches all the entire database to come up with some conclusion, summarizes what are possible alternatives to solve the problem. Who make the final call? Iron Man. When you talk about prompt engineering, all the data is there. It is only if you can ask the right question to the right depth that you're able to elicit a good answer. So you still need the human, but the humans need to upskill ourselves to the level where we can certainly do a better job. I can go through all the challenges on what's going to happen in the future. Many of the discussion took place this morning already, so I won't dive into it. But I like the discussion by ST Engineering about POC, POV, and then pilot. Why? Because AI is not a 24-hour project that you can turn on and turn off. AI is a journey that will work with you. It is something that you have to develop and cultivate. And I believe the use of AI is going to go beyond the traditional competence level. The use of AI will require us to move from what I call individual performance to perhaps a collaborative performance. In fact, one of the things that I have been talking to people about is that AI probably today is like a teenager. He's just come out from school. He thinks he knows something, but he needs a big brother, he needs a father and mother to guide. And we as humans must guide AI in the right space to perform the right tasks, to support us eventually. Well, whether AGI will take place or not, I do not know, but I'm pretty confident that AGI may not come into full practice within my lifetime. So I'm still good, and most of you are still good too, right? Here, what's important, how do we create the value to take advantage of this technology to support us? What's so more important is, as the big brother, as the big sister to AI, we need to know how to validate the output that comes up from AI. We need to know how we can then check back, associate, and build this into the practices, the problems that you're trying to solve. Well, somebody says, go for training, right? But we all know today, when we go to school, when we go to a training class, you are learning content just in case you need the information. Just in case learning. You go to a training class, a 5-day workshop, how much of the content is immediately applicable? Well, it depends. But what's important is you need to start to explore how we can go beyond that, right? How can we use AI as a tool to support us? And can we go beyond the standard just-in-case learning? And this is where I want to dive into a specific model that I have been advocating over the last 3 years. Just-in-case learning versus just-in-time learning. I co-authored 3 papers with a professor from Finland, and we presented it 3 times, different levels, and the application of just-in-time learning in a different space. Now let me elaborate. I talked about just-in-case learning already. What do I mean by just-in-time learning? The Japanese, Toyota in particular, came up with just-in-time manufacturing, meaning supply, demand, coming together at the right time. If content can come to you at the time you need it to solve your problem, that'd be wonderful. How can we provide content to you as you're trying to solve a problem in the factory space? So something goes wrong with the assembly line, right? You need to fix it. Do I say I wait for my next training class before I fix it? No. Do I say I'll sit and wait for my supervisor to come to you with information before I fix it? No. You have to figure out how to fix it. And to fix that, you probably need to get information. You probably got to learn just in time to solve your problem. Of course, there's another term called learning in the flow of work. And learning in the flow of work is actually very much promoted by a number of organizations. How do you learn as you work? And this is key. Now, to do that, there are a few things we need to watch out for, right? There has to be some foundation knowledge that you can't run away from, right? That gives you that basic. And then you got to get into a space of how do you use your skills to pick the right knowledge, to associate it into your content. And I believe we'll go through the process of memory retention. How much can you remember versus memory association? How you understand those content and associate it back to the problem you're trying to solve today. And this is very key because many times you go to a training class, you get 2 thick volumes of documentation, you put it onto your shelf, and you forget about it. It collects dust. So we need an AI tool that can come to you just in time for you to do your work. And to do so, I'm going to just skip this a little bit. To do so, I think we need to think about how we can start working in a very connected environment. Connected environment in the sense that today, when we work together, we work in a connected environment with our colleagues, with our supervisor. Something goes wrong, you pick up the phone, you call a supervisor. When something goes wrong, you talk to your colleague. Imagine as you move down the future of work, you have now an AI partner who you can go to support you to solve the problem. Just like what Iron Man has, right? Javis, can you explore this? Javis, can you look at this problem and give me some suggestions? If there's an AI tool that can come just in time to support you into doing the same work. And that brings me to the next point, right? Max Planck, we talked about quantum computing earlier today. And Max Planck, father of quantum physics, made this comment. When you change the way you look at things, the things you look at change. Well, let's think about it. When you change the way you look at things, the things you look at change. If today in your operations you face certain issues and you keep thinking about, well, this has never happened before, how do I solve it? Perhaps it's time for you to take a different look at it. Perhaps you can see some sparks. Perhaps you can see some solution. You see, the challenge with our life is we spend too much time looking at what can be done versus what should be done. It's easy for the researchers in the university to develop technology that can do this and can do that, can do this and can do that. But what should it be done to help you in your business? That's more important. I will just end off with this particular slide. I think there's a leak in the boat. There's a leak because whether it is the tariff system, whether it is the geopolitics, whatever, right? How do we fix it? The important thing is let's not ignore it. Let's not ignore it. And it's time for us to look at how we can use just-in-time learning to support us. Now, is there a practical application? The answer is yes. There's a Canadian company called VKS Application. Some of you may know them. They offer digital work instructions. So you've got this software as a panel where you can go to get answers to help you fix certain problems they're looking for. VKS software, you can look it up. I tried to bring them to Asia, not so successful yet. Maybe someday, they will come to Asia, and they may be available for our industrial application. So let's not try to compete with AI. I believe we will be smarter with AI rather than compete with AI. So with that, thank you very much for my time. I hope it makes sense to you, yeah?
Oliver, thank you very much. That was a very good first principles discussion here. Folks, since Oliver is not going to be staying here long with us for the panel sessions as he has to rush out, are there any questions for him? Anything that comes to mind from anyone? If not,
let me go easy.
There you go. There's the two questions there.
Sure.
Thank you, Oliver, for sharing with us regarding AI and humans, okay? I'm still perplexed. We, the humans who have created AI, why we are worrying about the AI? Because we are the one, the creator there. If you don't write something about it and it is not there in the data, that guy is not going to give you that answer anyway. And whatever you are mentioning, father of this, it has been written in philosophy also earlier, that we have to think philosophically in a holistic way to solve the problem. Unless, I know you have got some reservation about the university professors thinking about it, unless we think that way and try to probe and go deeper into that, AI is not going to be much useful to us. But I think you have given a very good perspective, and I appreciate that, okay? I believe there is no competition between humans and AI. I don't know why we are making it. Are we becoming dumb or smarter? I don't know. Your comments, please.
So, thanks for those comments, very good comments. In fact, I share the same perspective. Why should we be worried about AI? But I realized that one of the reasons why we are worried about AI is the media. I mean, you open the papers today, right? Retrenchment because of AI. AI displacement is accelerating. You name it, it's going on and on, right? So media. The second is probably because we do not understand what AI can do or not do for you. How many of us today have gone deep to write a code on AI? Not many. So we may not understand what it is. What you fear becomes what you do not know becomes what you fear. That is the issue. I was in Wuhan, China, 2 months ago. Got a chance to meet Professor John Horkoff from Cornell. He was invited by the Chinese government to be part of a education project 101. Why would John come all the way from East Coast to China for this project? Objective, to bring all the teachers in the top 2,000 university to be familiar with AI and use AI to teach the next generation. Secondly, to take the East content and West content and merge it into a huge database so that they can use this content to deliver to the next generation. Thirdly, every university curriculum will have AI as a foundation. Imagine this, in 5 years' time, every graduate from this top 2,000 university will have foundation knowledge on AI. Do you think they'll be afraid of AI? No. But it is us who may not be sufficiently familiar with AI that will fear AI. So we need to really understand what AI is, how it applies to us, and then we know how to leverage the technology. You go into a dark room, totally pitch black. You're afraid because you do not know where's the table, where's the window, where's the door. But if you're familiar with that room, even though it's pitch black, you have your orientation to move around. And that's what I'm trying to say. Get to know AI. It will help you to navigate and eventually be successful in leveraging AI. Second question?
Okay, thank you for the insightful talk. In early 80s, you know this, right? Most of the PhD topics and the R&D is about the pattern recognition and signal processing. Because the reason is when I asked professors why they more focus on this pattern recognition signal processing, they say you need only one computer and mathematics. Now today, because of the data takeover, that's why it has a lot of attentions. You can see from the revolutions of industrial, from steam power to today, how the intelligence is augmented to the machines or assets so that they can be self-learning. So my question here is, the artificial intelligence is all about the stochastic process, right? If you have a ABCD, the next letter would be the E, where the AI will predict, but it will not give a decision. So the human intelligence is more remarkable. You cannot override with any of these machines. Can you give us some insight on this?
Let me answer the question using a model. Most of us will be familiar with the Technology Readiness Index, TRI, right, or TRL, right? So most of the universities are very good with TRL 1 to 5, right? They do a lot of research, they write a lot of papers, they do peer reviews, they present it, everybody claps, right? But that is what I call lab work. It stays within the 5 people, it stays within a community of peer reviewers, right? It's good. But when you get into the level 6, 7, 8, and 9, and it gets into commercialization, that's where the human disturbs the technology. We all know that when we build a robot, it works in the lab. You bring it out to the shop floor, uneven flooring, you're going to have challenges. You've got inclination, you're going to have challenges. And those challenges are not solved when they are in the lab, right? So we face a tremendously huge challenge because while the technology may be good, it is not ready to be completely commercialized. They still need further testing, and that's where we, as part of the business community, needs to step up to understand the technology enough to perfect it, to make it usable. I remember earlier when we were trying to deploy the touchscreen kiosk to make a purchase from McDonald's, right? It was great in the lab, but when they deployed, a lot of elderly people could not place an order. Why? One simple reason, skin. The elderly skin has a different texture. So when they press, they could not activate the button, right? But that was not tested out in the lab. So those who commercialize the technology will have to look into something like this. When we deploy technology solution, especially to the masses, we deal with different type of people, different type of expectation. And hence, AI deployment is never an overnight project. It is a journey because you're going to encounter more and more new challenges, new problems, and you could solve them along the way. So TRL 8, 9, and beyond is a huge challenge. But if we are determined, if we know enough about the background technology, we would be able to solve the problem. Thank you for the question.
A big round of applause for Oliver. Thank you very much, Oliver. Thank you very much.